This video is going to show you how to find the coordinates of stationary points and determine their nature. Now that is exactly how the questions are worded, and I'm going to split it into two parts for you to start off to explain how to find the coordinates of stationary points, and then second we'll look at how we determine their nature. So first of all, to find the coordinates of stationary points, you need to differentiate the equation of the curve. Set that differential equal to 0, and when you've done that, you solve it, normally by some form of factorising, to find the value of x. When you found the values of x, you substitute them back into the original equation to determine the value of y. So if we have a look at that first part of the question, before moving on to determine their nature. So my equation is y equals x cubed minus 3x minus 2. The first thing I'm going to do is differentiate that equation. So working out dy by dx, I multiply by the power and decrease the power by 1. So I have 3x squared minus 3. I'm then going to set that expression, the 3x squared minus 3, equal to 0. Now, as you can see, this is a quadratic, which means I will have two values of x. So factorising, I can put a 3 outside the brackets, and I'm left with x squared minus 1 inside the brackets. That means x squared minus 1 is equal to 0. So x squared is equal to 1. So then I take the square root, remembering that there's a positive and negative solution when I square root. So my values for x are x is equal to 1 or x is equal to minus 1. At this point, I take each value of x one at a time, substitute them back into the original equation to find the value of y. So when x is equal to 1, y is 1 cubed minus 3 times by 1 minus 2. So 1 cubed is 1, minus 3 minus 2, which gives me a value of minus 4. When x is equal to minus 1, again I'm using the same expression to substitute in the value of x. So y is minus 1 cubed minus 3 multiplied by minus 1 minus 2. So minus 1 cubed is minus 1. Minus 3 times by minus 1 is plus 3, and minus 2 on the end. So working that out gives us a value of 0 for 1. So my stationary points are found when x is 1, y is minus 4, or when x is minus 1, y is 0. And you need to write them like that as a coordinate. So now, looking at the second part of the question, it asks me to determine their nature. What that wants to know is whether, at those points, is a maximum or a minimum. Now, the way to think of these, a maximum is like a hill, so it would have that shape. And the minimum is like a valley, so it's more like a smiley face. So to do this, you need to find the second derivative, substitute in each value for x, which you have found earlier on in the question, and then when you've done the second derivative and substitute in your x, if your answer is positive, it's a minimum, and if your answer is negative, it's a maximum. So just looking at how to do that, I'm going to split the page in half just so you can see everything side by side. So first of all, I need to work out the second derivative. So if dy by dx is 3x squared minus 3, my second derivative, so d2y by dx squared, same process, but I'm differentiating this expression now, becomes just 6x. So my first value of x was 1. So when x is equal to 1, my d2y by dx squared becomes, replacing that x there with 1, 6 times 1, which is 6. That's a positive answer. So at this point, that tells me when x is 1, there's a minimum. And then my other value for x was when x was equal to minus 1. So my second derivative, my d2y by dx squared, becomes 6 multiplied by minus 1, which gives me a value of minus 6. That's a negative number, which tells me it's a maximum. So now you can see that my two stationary points are at 1, minus 4, and 1, minus 1, 0. So at 1, minus 4, as you can see, there is a minimum. And then at minus 1, 0, there is a maximum. So looking at the second example, you can see this is from a past paper and is worth 7 marks. Worded exactly the same way. You need to find the coordinates and nature of each of the stationary points. The curve it gives me is y is equal to x cubed minus 3x squared plus 11.